Hello all, welcome to the subject of VLSI Design and Technology. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatipai, Janma Mujhe College of Engineering, Mohili, Pune. So today in this lecture, we are going to see how to. So this is the following circuit diagram. So we have to draw the state diagram for this circuit. What we have to do here. Sorry. So we have to draw the state diagram for this circuit. Draw the state diagram for this circuit. So here, this circuit includes 3 D flip-flops. D flip-flops is nothing but delay flip-flop. Whatever the input is there, which will produce output after a certain amount of delay or after every clock pulse, it will give the same output, whatever it is getting inside the input terminals. So what we are doing, what it is happen here, there are three delay flip-flops are connected here. So we have to derive the expression for each delay flip-flops. So what each delay or what each flip-flop will consist. So let's consider this D flip-flop. So D0 flip-flop, which is having. So at that, what this D flip-flop will do, whatever the input available after every clock cycle, it will certainly provide at the output. So what is the input of this Q1? So input is Q1. So whatever the information about on this Q1 terminal, it will provide at the output Q0. First, we will consider the inputs. Okay, the D1. What is the input of this D1? This D1, which is having the input Q2, and D3. Sorry, D1 after D2. So which is having the input, what input it is getting? See here, it is getting this XOR operation. So XOR gate is there. So the XOR gate having 2 terminal. So it will providing this XOR with this terminal. So this terminal itself having the another XOR gate. So which is having the Q2 and the Q0 here. So similarly, we have to write the equation for output also. So first we have to write output Q0. Q0, what is the output of Q0? So whatever the information getting from the Q1, it will simply forwarded to this Q0. So what is the output of this Q0? The Q0 simply having Q1. These are the outputs here. So what is the Q1? Q1 output, what it will getting, what are the input from the Q2 that will only getting at the Q1. So Q2. And what is the Q? So what is the output at this Q2? So this is an Y output. So this is an Y output. That is total output which we are getting back from this option. This is the Y. So this Y, see here, Y output terminal is connected. That is the simply input of this. That is simply input of this Q2. So what is the Y here? So what is the Y here? Y is this. Whatever the input present at this terminal, that is the Y here. So we have seen this is So this is the things getting at the D2 input terminal. So this is the operation. So we have to perform X XOR with Q2 XOR and Q0. So this is the expression for the Q2 terminal. So for this we have to, for this expression, these are the expected outputs. So we have to write excitation table for these outputs. So whatever the possible input should be given, and after that we have to draw the state diagram. So let's first see the excitation table. So which is having the output combination like Q2, Q1 and Q0. And after that we having the X is an input. So here X is an input, but there are two conditions. The X may be high signal and X may contain low signal. We have considered both here. Then whatever the output is available, we have to, these are the output. For this condition we have given like this. So this is the state. We have to consider the X state when the value is 0 and state of input when the value is equal to high. First, we have to provide the possible combinations. So, this is a 3-bit, is nothing but 2 raised to the power of 3. That is total 8-bit combination. 8 combination will be available there. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. These are the possible combinations of the output. So we can, these combination output we can get at these input terminals, data flowing through these input terminals. So we will give the name for each. Here we will give the name for each. So I will give the name for each here. This is having state A and this one is having state B. I will give the name accordingly here. The third one is nothing but C and this one having the D. So like this accordingly I want to give the name. F, G and H. So like for 0, 0 combination I am giving state A. For 0, 0, 1 combination giving the name state B and this one I am giving the name state. Like this name. Now we have to consider the input. Using this equation, we have to consider the input. At what input we should provide. This is the input that only we are giving. Only this input we are giving here. So according to that, this combination output we are getting. So first, to get 0, 0, 0 at the output of each flip-flop, delay flip-flop, what should be the input I have to give? So that's why I have to first perform the operation here. We have to perform the operation. See the D0. First, we have to consider what is the output available this terminal. So Q2. So Q2 is available the XOR operation of all the things. Now our X is 0. Okay. Now our X is 0. So I am considering 0 and Now for this combination, now assuming Q2, Q1 and Q0 is 0. So if I want to find the Q2 for x equal to 0, I want to find the Q2 for x equal to 0. So what I will get? See here x equal to 0 and here XOR. So XOR with this Q2 is also 0 and XOR this Q1 is also 0. So what is I am getting here? Combination 0, 0, 0. See. Sorry, but I am getting 0 here. Output is here 0. For Q1, what is the output we are getting? So what is the Q1? Q1 is the output of output of Q2. So now what is the Q2? Q2 is 0. And Q0 is equal to output of Q1. So what is the value of Q1? Q1 is 0. So at the end, what we are getting? The Q2 is 0, Q1 is 0 and 0. So getting here what we are getting? Combination 0, 0, 0. See, when x is equal to high. When x equal to high, what will happening here? First consider Q2. When x equal to high is nothing but high, XOR with Q2 is 0, XOR with Q1, that is 0. So the XOR operation, what happened here? 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. So here this 1, 0, 1, 0 combination is nothing but 1. So here we are getting 1 and XOR. So XOR with this 0. So XOR with this 0. So that is, so 1, 0 here, 1, 0, 1, 0 is nothing but high. So at the end, Q2 is getting high and Q1 output is, what is the Q1 output? Here Q1 is a 0 and Q0 is as equal to, that is also 0. So what is the possible combination we are getting here? We are getting 1, 0, 0. So we have to write here. So 1, 0, 0. So like that we have to write. So we have to calculate for all those these combination from 0, 0, 1. Now we have to pass this data with the input x here. Then certainly we are getting the values here. Then after that we have to decide the state. So let's see. So for all the possible values, we have to calculate this present state. So let's see now. See here, for 0, 0, 0 combination of the output, so x should be 0 and x1 should be 1. Then this combination we are getting. So if we provide this combination, then the output will become 0, 0, 0. Similarly, we have to identify all the possible inputs at this particular output. So this is the excitation table. So here we are giving a numbering here. See here. So according to that, we have to identify the output also. These are the possible combinations of the input. So to get Q2, Q1, Q0, when x is 0, x is 1. These are the possible combination of this q2, q1, q0, q2, q1, q0. So let's give the name for each here. Let's give the name for construct the diagram here. So respectively, we have to give the name A, B, C, D, E, F, G, H. So like that, we are giving the possible combination of the present state here. So see here, 0, 0 is nothing but A. Here, 0, 0 is nothing but A. And the 0, 0, 0 is nothing but A. And 1, 0, 0, 1, 0, 0, 1, 0, 0 is nothing but E. So like that, this table is organized. And these are the possible combination output. How we can get the output, how we can get, see here. This is the Q2. Whatever the Q2 is there, that is the output. See, this is the Q2, Q0, Q1, Q2. So this bit we will consider output. When x equal to 0, Q2 is 0. When x equal to 1, Q2 is 1. Similarly, when x equal to 0, this Q2 is 1. So x equal to 0, Q2 is 1. When x equal to 1, this Q2 is 0. So like that, this table has taken. So 0, 1, 0, 1. 1 0 1 0 1 0 1 0 0 1 0 1 1 0 and 0 1. Like this combination is taken output. This is the output, this is the present state, and this is the next state when the according to the condition of x. This is the present state, this is next state, and these are the possible outputs. So based on this table is the state table. This is called as a state table. So we can easily identify state changes. So this is called a state table. So we can find this. So 0 0 is nothing but 0 0 is nothing but A. So A. So 1 0 0. 1 0 0 is nothing but what's the 1 0 0? This is the E. So the state changing from A to A and A to E, like that. When input is 0, the state is changing from A to A. When input is I, the state changing from A to E. Like this. This is the state diagram. So like this, all the possible combination we have written here. So B. So B is nothing but 0, 0, 1. So here 1, 0, 0 combination will be there. So 1, 0, 0 is nothing but E here. So similarly, 0, 0, 0 is nothing but A because A having 0, 0, 0. C. C is nothing but 0, 1, 0 and B. So B is nothing but 0, 0, 1. So where is the 0, 0, 1? C. 0, 0, 1 having this B. So we have written B here. Then 0, 1, 0, sorry, 1, 0, 1. So 1, 0, 1 is nothing but what? F. So this is the 1, 0, 1. D. 0, 1, 1 is nothing but D. So we have written D here. And F. F. F 0, sorry, 1, 0, 1. So 1, 0, 1 combination is written as a state F. This is the state F. So like that, all the possible combination state we have written here. These are the Q, and this is the Y output. The Y output kept as it is. So using this table, now we are going to drawing the state diagram. So let's draw the state diagram. So the state diagram having how much state here? A to H, this much of state. So we have to consider all those states. So I will explain in the next slide because it will take this huge space for explaining that. So let's consider all the state first, one by one. State will be considered by the circle here. So let's consider all the state here. Okay. So let's start from A to A. Okay. The state changing from present to next. So A to A. So first I am considering this one is A. Sorry. So first I am considering this state is A state. First I am considering this state is A, and which is moving A to A only. So I am considering that I am considering A to A. The state changing here A to A at the possible input is 0 and possible output when x is 0, that is 0. So this is first state. Then the state changing A to E. The state is changing. Let's consider this one is E. The state is changing from A to E. Then what are the possible inputs when x equal to high? When x equal to high and the output is also high. So similarly B to E. So just consider here this one is B. So what will happening here? The state changing from B to E. The state changing here B to E. What are the possible inputs? X0 and this is high like this. So similarly, the state changing from B to A, the state changing from B to A when the X is high and this is also low. So this is the way of writing the state diagram. Let's consider C. So I am considering C here. So let's changing the state C to B. So changing the state C to B, one X is equal to 0 and output is C to B. This output 0, 0. So this is the possible combinations. When C to F, C to F, C to F changing when X equal to 1, Y equal to 1. What is the value? X equal to 1, output is 1. So when X equal to 1, output is 1. Then next state change, C is completed now D, E to F. Where is our D? Let's consider this one is D. D to F. So consider this one is F and this one is here another will consider here D, C, E will happen here and this one is H, this one is G and this one is F. So now state changing from D to F. So what is the possible combination D to F when x equal to 0 and x equal to 0? Both are 0. See x equal to 0, x equal to 0, here x equal to high. So 0, comma, high. Then D to B, where is B? B is here. D to B, when input is high and whatever the possible output, that is 0. Similarly, D to, now D is completed. Now state E to G. Where is the E? Here, E to G. So E to G when x equal to 0. We are taking when x equal to 0. At that time, what we are getting output, that is 0. Then E to C. Where is the C? Here. We have to consider E to C. So we have already taken E to C. E to C because x equal to 1 and the both are high. So this is already we have taken E to C and E to V. So simply I am giving a bidirectional signal here because the both C to E and E to C both having input high and output high. So like that, then F to C. Where is the F here? F to C. F to C. The input is 0 and the output is high. While zero combination, when the zero combination, the output is high. And F to G. This is F to G. F to G. Here, when input is high, the output is also 0. When input is high, F to G, the output is 0. High, low combination. This is the state diagram. Then G to H. G to H. G to H, when x equal to 0, output is high. When x equal to 0, output is high. G to D. G to D. So this is G to D. What is the possible combination G to D? X equal to 1, output is 0. 1, 0. Similarly, H to D. See here. H to D. H to D. So what when x equal to 0, what are we are getting? 0, 0. So 0, 0. Then H to H. H to H we can give like this also. H to H, when input is high, then the output is both are high. Sorry. H to H. The input is high. This one is also high. So these are the possible combination. So we have drawn in the state diagram.